Well, hello and welcome once again to the Waters and Stanton video channel. Subject today is mobile operation, but not normal mobile operation, because I know a lot of you, when you go mobile, you don't actually operate on the move. You park up and then you operate what we might call mobile. Some would argue it's portable operation. Bit debatable, but it doesn't really matter. A lot of you I know will put a rig in the car, put a whip on the roof of the car or on the back of the car, and see what you can work on the HF bands. There's nothing wrong with that. It's great fun, but sometimes you yearn for stronger signals. And I know that a lot of you think, well, okay, well, let's see what I'll have the rig in the car, but I'm going to use an external aerial, which is fine. But sometimes it's a bit of a faff, and I've been thinking about ways of making it so much easier, so much quicker. Now, there are several ways, but the way I've been experimenting with very recently, and it works extremely well, is to simply use a length of wire. Now, there's nothing cheaper than a length of wire. All you do is you remove the whip and you replace it by a length of wire. Now let me explain. Your mobile whip is a quarter wave. It's a quarter wave whip, but it is loaded to make it shorter. I know some people operate full length antennas. You can do it on 20 metres with 16 foot of wire or 16 foot of telescopic rod. It's quite tall and it needs a bit of support, and you've got to be careful where you put it, and if the wind blows, it blows around and puts a strain on the mount. So what I thought was, why not just use a quarter wave length of wire? Now, if you're at home operating a base station and you put a quarter wave length of wire in the end of your transceiver, you're going to get all sorts of problems. You're going to get common mode problems, you're going to get RF all over the place. It's a right mess and I wouldn't advise it. But it's totally different when you apply that principle to a mobile setup. So why is it, or should it be so different? Well, the reason it's different is because your car is a massive, great big chunk of metal. It's a very, very nice earth. The bigger your car, the better it is. Now, I happen to be using a camper van at the moment. Camper van, it's a van conversion. It's not very big. It's only 5.4 metres long, but it's a big chunk of metal. And as I think you may have seen in earlier videos, I can't mount a mag mount on the roof because it's corrugated, so I've got the mag mount on the side of the vehicle, and it works extremely well. So I thought, what happens if I take my mag mount off, or rather the whip, take the whip off of the car and replace it with a quarter wave length of wire? Well, there's a very simple way of doing it. I believe, and you'll have to check with this, I believe if you get a banana plug, you can actually put a banana plug into an SO239. Not quite sure about that. But what I did, I made up a little adapter, which I'll just show on the screen now. I used a BNC adapter with two banana connectors for wire connections, and then I got a PL259 adapter which will mate with the BNC connector on that banana adapter there, and the end result is you've got a PL259 plug that goes in and you can make wire connections on the other end. You don't have to connect the earth side of the banana adapter because that's effectively connected to the vehicle. So you see, this adapter enables me to now attach a length of wire. So I attached a quarter length of wire on 20 metres, a 20 metre quarter wave, which is 5 metres long. It's not a great length of wire. And I was quite impressed with the results I got. Now here you see the adapter installed, and it fits quite nicely onto that right angle adapter. And here you can see the VSWR curve, which is excellent. I was quite impressed with that. And then I ran that wire from the van, quarter wave wire, to a temporary mast at home here just for the purpose of testing. Now the beauty of this is that it's full size, so you get very good efficiency. Okay, one can argue that the height above the ground is not great, but what you can do is if you carry with you a short telescopic mast of some sort, fiberglass section mast, say it's 15 foot high, what's that, 4 or 5 meters high. If you have a mast like that, you can put it at the far end and get the aerial in the air. Now my van is around about, I think it's about 15 foot, something like that high. Very low that, probably about 12 foot high. Anyway, it's higher than the average car, but you can run a length of wire from that to a bush, to a tree or whatever, and you've got a horizontal quarter wave. If you have the far end higher, then it's going to go up, and it's quite a good antenna. It works quite well. And the beauty of it is you've got a full-size antenna. You don't need an antenna matching unit, and you get excellent bandwidth. You really can go right across the band without having to actually bother about changing the length of the antenna. Now, if you want to make things even more interesting, what you could do is you could try an end-fed half wave. Now, an end-fed half wave requires a matching transformer, but I've devised a simple way of connecting a matching transformer to your mag mount or whatever SO239 mount you've got on your vehicle. Just take a look at this. Here's my homemade matching transformer, which I have covered in a previous video. It's got an SO239 on one end, and the other end you've got the clamp for the wire. Now you need a PL259 to PL259 joiner like this, and you plug that into the SO239 on the matching unit. This then enables me to plug the matching unit straight into the magnetic mounts, and I've now got a 49:1 matching unit mounted on the side of the vehicle. Now the advantage of half wave is it's a longer antenna, it's right out in the clear, and you get very, very good results with that. But there's another advantage. You see, if for example you had your end-fed half wave on 20 meters, there's a 10 meter length of cable. Now, if you remove the matching transformer and connect that wire directly to your SO239 socket on your vehicle, you've then got a quarter wave on 40 meters, and it works very well. And you've also got a 3/4 wave on 15 meters. Now, it won't be absolutely perfect, but I think you'll find the VSWR is low enough. So with this 33 foot length of wire or 10 meter length of wire, as an end-fed half wave it works on 20 meters. As a quarter wave it works on 40 meters, and as a 3/4 wave it works on 15 meters. And then if you get rid of that and go back to your quarter wave, your 5 meter length of wire on 20 meters, if you insert your 49:1 matching transformer, that then works on 10 meters because it's a half wave long on 10 meters. So with 2 bits of wire you can cover 10, 15, 20 and 40 meters. I'm sure you can think up other combinations as well, but it's a very quick way of turning your mobile system into quite an effective portable system. The van, as I've said, is 5.4 meters long, a lot of metal there. And this is the Jackery power supply which I use, which is great, 240 watts, and it's amazing. I've used it all the time for all sorts of things. I normally sit in the rear passenger seat because I've got access to the table, and here you can see the Xiegu G106 on the table. And there's an interesting little cubby hole on the floor. Right, lift it up, you can see I can store my radio equipment in there and put the battery in there. I don't use the vehicle leisure battery, I prefer to use the Jackery one, and that works out quite well. Now I've been using the Zigu G106 for my tests, and I'll cover that radio in detail in another video. But it's a nice little portable system, and if you have got a noise problem at home, it's a good idea to try this because it doesn't cost anything. All you need is a length of wire. You're going to go quarter wave operation. You do need a 49:1 transformer if you're going to use an end-fed half wave. That's your choice. But I found that it's a very, very effective way. And as I said earlier, you don't need a matching unit, so you can feed the aerial directly from your transceiver. You get excellent bandwidth, far better bandwidth than you get with your mobile whip, because that mobile whip is quite short, and that means it's higher Q, narrower bandwidth. And it's a good experiment because, you know, ham radio is all about experimenting. I've been very impressed with the way it works, so I would encourage you to try it out and see how you get on. So there we are. That's my idea for a low cost, efficient and very quick to install portable system that you can use in conjunction with your mobile setup. There we are. As always, thank you for your support on this channel. It's much appreciated. I get lots and lots of very interesting texts. People have comments and they've got opinions, and sometimes they've got some very interesting ideas. Ham radio is all about experimentation, pushing the boundaries, sometimes keeping the costs down. Because in these times at the moment, we're going through a very difficult period. And if we can get some useful contacts, get some enjoyment simply with bits of wire, then why not give it a try? So thanks for your support on this channel, much appreciated. Enjoy your ham radio, get out in the open, get out in the sunshine while it lasts, of course, and take care. Look forward to, as usual, seeing you in the next video. Bye for now.